I do have a bit of a checkered past, but throughout this whole time, I've been a strong advocate and practitioner, as I would like to call it, of open science practices, right? And this whole thing came from a conversation I had with my colleague Jennifer Ding from the Alan Turing Institute last year, when I was saying, like, I'm getting annoyed about all of this hype around so-called AI, and I wish we could stop talking about it. And I'm standing here talking to you about it right now. And this irony has not escaped me, but I would like to thank Jennifer in helping me to turn my little rant into something that's hopefully a little more productive for all of us. There are a lot of problems in this space, especially when it comes to science and reproducibility. But some cool things are happening, right? My other colleague Sharon T was just telling me about this really cool tool called speech schema filling, which was developed by a bunch of experimental chemists. And what's really cool about it is that it's a tool that you run on your computer, and then as you do your experiment, you talk into your computer, and then it uses a speech-to-text model plus a locally run large language model to transcribe what you're saying into an electronic lab notebook. And what's, I think, most cool about this tool is that rather than just dictating what you're saying, right, it actually parses what you're saying into structured metadata about your experiments so that the details of your experiments are recorded as you do it. So I think this is really cool, lots of potential here, which would really help with documenting experiment-based scientific research. It helps with data quality and reproducibility, as long as you're willing to talk as you do your experiments. Now, this is a cool example, but I think a lot of us share a lot of concerns about what these so-called artificial intelligence technology would do to us in terms of how it affects academic research.
It's just gone off for some reason. You've got to wake it back up.
You might want to change to the HDMI thing. Does that work?
This one's gone off.
Okay. Oh, yes.
Right.
Okay. I do have a backup on this this computer if we can get it on. I'll just do it from here. Are we good? Ah, yes, we're good. Okay, can I keep going?
Yeah.
Okay, no. This is by design. I think there's a lot of understandable concern about these technologies, and I just want to really quickly share with you what I think is one of the greatest hits that we've seen over the past year. So there was this paper published in Frontiers in Cell and Developmental Biology. Some of you might have seen this paper, so you know where I'm getting at with this. When you first look at the paper, you'll see lots of text that's obviously generated with large language models. But what's most remarkable is that it came with a figure of a lab rat with giant genitals sticking out of it, okay? You can see that part of it actually extends beyond the figure. That's how big it is. And I was so impressed that, this paper got past the peer review, it got past the editor, it got past the copy editor during the production process. It was published, and that's how it became really infamous, since February of this year. And on the other side of this, there's also some evidence that academics are using large language models, ChatGPT, that kind of stuff, to generate the peer reviews that they give for papers. So obviously, some problems here. And with that in mind, there are three things I want to cover today. One is that words matter a lot when we talk about so-called artificial intelligence, right? First of all, it is actually not a technical term of art in terms of what's actually happening in the world today. It is a marketing term. And it covers a bunch of different technologies, and the term actually leads to a lot of ambiguity. And within scientific circles, people are also advocating for how a lot of these artificial intelligence technologies should be open source, right? So we know how it works. But we see things like, when Meta launched their Llama 2 large language model last year, they call it open source, when in fact it came with a lot of restrictions on who can use this tool and what they can do with it. And a lot of parts of this model is actually completely opaque to us, and we're not allowed to know how it actually works. So it is very much not open source, certainly not in the sense that has been widely established in software circles where this term came from. And this was actually covered in a paper by Whitaker and West last year, talking about how this kind of open washing, right, this kind of ambiguity actually allows us to hand over our autonomy and power to the big players that developed these so-called AI technologies. And it further entrenches their hold not only over society, but the science that we do. Now, there is ongoing work, really good work by the Open Source Initiative, talking about how do we actually define terms like this. And I think it is important for scientists like us to be part of this conversation. The other thing is that in terms of having a good grasp and understanding of what these terms are, I also advocate for a more outcomes-based approach to thinking about artificial intelligence. Whether it's dealing with what we want to see for reproducibility in science, trustworthiness, inclusion, accountability, or the safety of this technology, I think we really need to think about what do we want to see as an outcome in the end, rather than focusing on the tech itself. I want to go through some examples, but to understand that, I think it's important for us to realize that what's often called artificial intelligence is foundationally very similar to the spell check that we've been using in our computers forever, right? Spell check takes an input, in this case, a text you typed, into a computer, and it goes through a statistical process to give you an output, in this case, a suggestion for how you should spell that word. Now, a lot of the large language models that we see today is, on a fundamental level, basically, spell check, right? It's just a very, very sophisticated set of statistics, but it is statistics nonetheless. And underlying all of this technology is enormous amounts of human labor that goes into labeling and processing the huge data sets that were used to train these models. If you really look at what's happening behind the scenes, companies like Meta and OpenAI and those big names, they hired countless sweatshop workers in African countries, in this case Kenya, for them to filter and process all of the underlying information that's fed into these models. And every day, they sit in front of their screens to screen out text describing things like murder, suicide, sexual violence, and all of those things. And we never hear about this. And I think the lesson to take from this, I think is really summed up really well by Kate Crawford, who says that what we're calling AI today is neither artificial nor intelligent. And, Lily Irani described it as, it's not really replacing labor per se, it is actually just displacing labor and making it even more invisible than it already is. So some people might ask, okay, so what does science have to do with this? Well, first of all, I hope you care about the fact that there's a lot of sweatshop workers helping to build these models anyway. But for scientific research, again, recognizing that what people call open source AI is neither open, artificial, nor intelligent, there was actually a paper that was just published a few weeks ago where they took 40 of the most commonly used large language models that you can find on the internet these days, and they evaluated its openness along 14 different kind of factors. And you can see that an overwhelming number of these models are either completely closed source and opaque, or just a little bit where you can maybe see a little bit of its behavior, but you have no idea what's happening under the hood. And notably, ChatGPT is right on the bottom there, coming 40th in this list. So what does this mean for science, right? Well, I think, first of all, it really harms reproducibility. And what I mean is that, there's so much talk right now about taking so-called artificial intelligence and incorporating that into the science that we do, right? And I have seen papers in really, really prestigious journals, those big names that we've all heard of before, where they're saying things like, oh my God, it's so much work for me to recruit participants for my study, So let's replace a bunch of them with chatbots, who will never grow tired of my interviews and will answer any question I ask for my qualitative research. There are also other papers that propose using so-called AI to design experiments and run those experiments. But again, coming back to the fact that this AI stuff is completely opaque to us and we're not even allowed to know how they work, right? So if we use them and incorporate them into our work, we're not doing science anymore. I think we're doing alchemy instead. And I think this is extremely dangerous for scientific research. And it will lead us to what Lisa Masseri has described as illusions of understanding. And I don't think this is the kind of science that we want to do. Okay, so coming back to open science, which is something I talk about a lot, I really want to come back to this infamous lab rat here. When some people see this paper, they would say, oh, okay, maybe we should just ban the use of generative AI in the writing, right, of scientific papers. So, that will solve some problems, but it also makes me wonder, about if and what kind of problems are we actually solving if we focus on dealing with AI. What I mean is that, we might inadvertently think that we've solved the problem when we are actually entrenching a much deeper problem, right? So let's think about, those really big academic publishers that we publish our papers with, and we all know who they are. Now, let's say today one of those publishers say, hey, we came up with this new tool to automatically detect AI-generated papers to help you reject them more quickly, right? And that sounds like a good solution. And maybe it will help the editors and the peer reviewers, reduce their burden a little bit. But on the other hand, quote-unquote solutions like this, would further tie us into these really big publishers who not only hold so much power over academic communications, but it will entrench their positions when they are very much the cause of the broken peer review system and the broken publishing system to begin with, right? So if we only fixate on the AI itself, we're going to make problems worse. So let's support existing open science initiatives that are happening. There's the new Octopus platform supported by JISC, which we were going to hear about today, but hopefully we will get to hear about again later. People are proposing open peer review. There's the UK Reproducibility Network, which we just heard about. And then there are all of those computational notebooks that we can use to publish our work in a more reproducible way. But going even deeper than this, right? We also need to think about long-term problems like the job precarity and then toxic workloads that academics like us have to put up with. It is because of these pressures that some people among us are pushed into academic misconduct. And AI didn't create these problems, just as how AI didn't create sweatshops, okay? So AI is not the problem. At least it often isn't. What AI does is that it highlights existing problems that have been around for a long time, and it's a reminder for us to address those deeper problems instead. Okay, so the few things I talked about today are, first of all, words really matter a lot. We need to understand what these words really mean. We need to be careful about their meaning and usage. We should think more deeply about what the underlying issues are, because very often AI itself is not the problem. Okay? And if we focus on AI, we will make those problems worse. And finally, when it comes to reproducibility, if we do incorporate these so-called artificial intelligence technologies into our workflows, we cannot rely on the closed AI that's being really marketed and hyped these days. Otherwise, we will only be doing alchemy on a fundamental level. Okay, so that's my really short spiel right there. I hope there are some useful concepts that we can take forward. And lastly, I would just say that in the spirit of what we're doing here today, I have tried to make this talk reproducible. So not only are the editable slides published to Zenodo, I've also included the full transcript and a video recording, and all of the other references and further reading that I've referred to in this talk. So hopefully, you can find some use in that as well. And please feel free to critique, make use of, and remix this talk from Zenodo. Thank you.